I want to show you how to use a table of additivity parameters to predict the chemical shifts for the carbon atoms in a benzene ring compound that has substituents on it. Let's draw the structure first. Here we have a benzene ring. We need an example here, so I'm going to put an OH at this position and a chlorine at this position. And the question is going to be, what's the prediction for the chemical shift at this carbon here that I'm showing with a black dot? What would be the chemical shift there? Well, there's a calculation that's done. You start at this carbon and you say the base number is 128. So you'd start 128.5. And then that's what it would be if this were just benzene and had no substituents. To account for the substituents, we first look at the hydroxide. Where is it? The hydroxide is meta to this carbon. So we go to the table and we find hydroxide, and we find the meta value is 1.4. So that we would add then 1.4. What about the effect of the chlorine? Well, the chlorine is para to this carbon. And so we go find the chlorine in the table and then go over to the para contribution, and it's minus 1.9. So minus 1.9. So if we tabulate all of that together, we'll have the prediction of 128.0. So in this case, in this instance, these two substituents have the effect of canceling each other out. So the actual prediction of the shift here for this carbon is about what it would be in benzene. But of course, you have other possibilities with other substituents. So you just look and see if it's ortho, meta, or para to the carbon that you're calculating, add in that contribution, and sum them up. The term ipso refers to a substituent that would actually be attached to the carbon that you're working on. So if you were working on this one here where the hydroxide is, the contribution from the hydroxide to that carbon right there would be plus 26.9 as indicated in the table. So hopefully this gives you the means of using the additivity parameters to make predictions.